Hello, everybody. Today, I want to explain about a project that we want to do about it. Its name is QV. It's a UV satellite, and I have a presentation for that. And now I want to explain my presentation to you. Now I want to share my screen. Yes. It's about star clusters observation in the UV, ultraviolet. Some scientists have done some surveys about the properties of hot stellar populations in the galactic globular clusters in the UV. Horizontal branch morphologies, blue chains and gaps, blue stargular stars, and low luminosity UV objects as discovered optical companions to millisecond pulsar in binary systems. Ultraviolet in all the stellar populations. The ultraviolet light in all the stellar populations of galactic globular clusters, or GGCS, is dominated by hot stars such as blue horizontal branch stars, blue hook stars, extreme blue horizontal branch stars, blue straggler stars, post-asymptotic giant branch stars, and hot subdwarfs, galactic globular clusters in the halo region of the Milky Way are less crowded in UV, and hence their observation in the UV regime allows one to probe and separate the bright stars effectively. As you see here in the main sequence, you see some stars that I mentioned them. Photometric and color magnitude diagrams of galactic open clusters. Compare the color magnitude diagrams, or CMDs, to theoretical isochrones and find good agreement between the theoretical isochrones and the CMDs. And Siegel et al. Measured the photometry of stars in 103 open clusters using the Swift or U-Boot telescope. They analyzed 49 of these clusters using Gaia data release 2 and spectroscopic studies to separate member stars from the field to study precise CMDs and compare the CMDs to theoretical isochrones. Their main results were the theoretical isochrones reproduce the features of the CMDs very well. And second, using these isochrones, they measured age, reddening, and distance for 49 clusters with well-defined color magnitude sequences. In Figure 1, you see the CMDs of the open clusters NGC 2447, Berkeley 39, NGC 2477, and ISO 12326 from left to right. And the solid lines are parsec Calibri isochron set to the parameters. Filmed red squares show astrometric members selected from Gaia data release 2 by CG18, while open circles squares are spectroscopic members from either MMU. And a study of UV bright sources in globular clusters using ultraviolet image observations. By using UV optical color magnitude diagrams, or CMDs, we could identify and characterize the sources of different evolutionary states. For example, blue horizontal branch stars, extremely blue horizontal branch stars, blue straggler stars, variable stars, and etc. We could estimate effective temperature, surface gravity, luminosity, and hence the radius R of these hot stars by fitting the spectral energy distribution, or SED, with the help of stellar atmosphere models. UV or ultraviolet properties of galactic globular clusters with integrated colors. Determine how the integrated UV colors are driven by hot stellar populations, primarily horizontal branch stars and their progeny. We could investigate how the UV colors vary with parameters like metallicity, age, helium abundance, and concentration. And D'Alessandro et al. In 2012, they presented ultraviolet integrated colors of 44 galactic globular clusters. Integrated colors of 44 galactic globular clusters observed with the Galaxy Evolution Explorer or GALEX in both FUV and NUV bands. This database is the largest homogeneous catalog of UV colors ever published for stellar systems in our galaxy. The proximity of GGCS or galactic globular clusters makes it possible to resolve many individual stars even with the somewhat lower spatial resolution of galaxies. They found for the first time that GCS associated with the Sagittarius dwarf galaxy have FUV-V colors systematically rather than GGCS with the same metallicity. Finally, they speculated about the presence of an interesting trend, suggesting that the UV color of GCS might be correlated with the mass of the host galaxy in the sense that more massive galaxies possess bluer clusters. And in this figure, you see that the comparison between galaxy CMDs of two globular clusters connected with the Sagittarius stream upper panels and galactic globular clusters in the same metallicity regime in lower panels. They picked two clusters associated with the Sagittarius stream and compared them with the galactic globular clusters of similar metallicity. The photometric catalogs have been corrected by distance modulus and reddening values reported by H10. The HPs of the stream clusters are homogeneously populated in color and magnitude. In contrast, the galactic globular clusters show an obvious increase of star density towards higher temperatures and bluer colors. We want to do for more distance clusters and for all available distance globular clusters. This is our aim for this project. And thank you for your attention. See you next time. Bye.